We'll speak about MySQL replication again, and this time is how can you get most out of your slave? So the question is why, if you want to scale by having multiple slaves, right, by using MySQL replication and using multiple slaves, you have a bunch of problems, right? One of the problems, you have to keep your writes on the master down, because if not, replication might not catch up, or you have very little spare cycles on the slaves to do any useful read works. You have to figure out how to utilize resources on those many slaves efficiently, and you also have to figure out how to use your application so you actually can put a lot of reads on the slaves, which can potentially contain stale data, without impacting your user experience. But first, let me get back and this goes back to Baran's talks about scaling for simplicity, and the question is, do you really need that? And I would say many people recently have been saying, hey, you know what, we don't want to go through this pain during the asynchronous replication. Let us just run a replication from the master server and use the slave simply for some, let's say, reporting jobs which are not kind of production critical, for backups, for availability. And I think for many applications of rather reasonable size, that actually can also be a hunter. And it's also interesting what for huge applications, the just replication is not an answer anyway. I mean, if you look at the guys like whom I use a lot of MySQL, like Facebook, or the secret dating site out there, they cannot just survive on their MySQL replication alone. So they just also have to shard the data. And another thing here is also caching. Like in a lot of cases, we see people being able to reduce number of slaves dramatically because they just cache the data, right? They reduce the number of reads so much, and a lot of those reads go to memcache right now, so they don't need a lot of slaves, right? And don't need any slaves at all for scalability. So what can we do to reduce your write rate? Well, first of all, it's best to travel back in time, and if you haven't been there, to go to my Fighting in MySQL Replication Live talk, where I explain a lot about MySQL replication optimization. And to sum things up, you want to analyze the write queries and optimize them in a various way. You can, some of the helpful things are using proper indexes, or if you have like wide tables, like some people have like user table with like 200 fields. Well, it's very often helpful to split that into heavily frequently modified data and not, because this will make updates a lot faster. And going kind of back to my InnoDB optimization slides, which I think kind of similar to mine some, well, when you modify rows, it's kind of the whole rows which you have been written to. And with InnoDB, the whole rows go to log, the whole rows have to be copied to undo space. So it makes it all much slower than rows alone, right? And you can do updates to very short rows much faster than to rows which are several kilobytes inside, even if you just change one simple counter column. It's often helpful to merge your queries. Like you may say, okay, instead of doing updates for each counter columns, aggregate it in some way, right? Or like it's very helpful for log processing, for example, when you can pre-aggregate data in the application and then do it in bulks. Or you can throw away some queries from a replication standpoint. For example, if you're creating some temporary tables just for purposes of running select queries on them, you can configure your binary login so those updates, those temporary table creation do not go for replication at all. So Another things here are ideas for reducing replication traffic is, well, do you really need to replicate all tables? In some cases, you're not. When we are speaking about using slaves for high ability, I would prefer kind of to have a full copy because otherwise the recovery scenarios become pretty complicated. But in some cases, that may be a fair trade-off. Now, moving some tables to another instance is a good idea. In some cases, like you say, oh, I'm also logging to this database, but really, for my logs, I don't need the high ability, and I don't need those logs on all slaves because they're not joined to anybody anyway. So just put them somewhere to a different place. Do you need overrides happen to database at all? I mean, there could be some stuff which can move from a database, like say, oh, session tables. Maybe we can use something less like memcache for that. Another ways to optimize traffic when we go back back to the slave now is to think about the indexes on the slave. The beauty of MySQL statement-based replication is master and slave don't have to be equal at all. They only have to be equal enough for queries to produce relatively same results. So you can have a different indexes, even sometimes different storage engines on master and slaves. Now, storage engine, I mentioned again. I'm not a big fan of the different storage engine of the slave, but that works nicely for some cases.
Sometimes it's useful to have black hole type tables on the slave.
What's that?
But sometimes it's useful to have the black hole.
Well, yeah, I would say that is sort of some way you can do it for the kind of pass through, like filtering slaves, and it also can be useful if you want to skip some of the tables, but it's easier to use maybe easier to use black hole tables instead of having replication filters. Another thing I would mention, in some cases people choose to bypass MySQL replication and simply copy the table every so often. For example, you can say, okay, well, I have this table which needs to be created with some very complex selects, right? Some aggregate queries and then distribute it everywhere. Or you can just copy it, in particular it's MySum table. That is, for example, very helpful if using MySQL full text search. Full text search indexes can take quite a while to build. And you can just build on one server and then distribute them by copying instead of slave. Now when it comes to utilizing slave resources, well, what do you say? Yeah, well, one of the things here with slaves is storage. The more slaves you have, the more data duplication you have. And as your application grows, you have both increase in the data size, typically, as well as the number of slaves, if you're trying to scale by replication. So your storage needs could be growing as n square, as your application size grows, which is not nice, especially if you look at the high-end storage, which can be expensive, not just $100 per terabyte, as we have for the cheapest drive. So what can we do here? Well, there are different solutions. Like one of them is obviously sharding, which goes back and says, hey, don't just rely on MySQL replication for scaling. Then there is consolidation. Maybe to avoid so much storage duplication, you can simply use many slaves, maybe more powerful slaves, right? With even more memory, CPU power, maybe some other enhancements. You also can do partial replication as a solution for this one, and it could be based on tables or based on data. In some cases, you may choose to archive data from the slave faster, or archive data from some of the slaves by simply pretty much deleting the old data from them. Another problem is yes.
But then doesn't that break replication when you finally do it on master?
No, well, the idea is Well, in this case, you can delete the data, right, from the slave. And depending on your traffic, it could be like your inserts and updates just go to the recent data, and then you delete, or you can delete the data from master with no bin log, and then from the slave with no bin log, and then it will remain on some of the slaves which are archiving slaves. Now, the other problem is the duplication of the stuff which you have in memory. Because the slaves, they at least have the same replication traffic and very often have the same kind of read queries passed to them. So their cache content is duplicated. So when you're thinking your effective cache would be like 10 slaves with 32 gigs each, oh, I'm having like, what is it, like 300 megs or gigs, right, of cache. Well, your efficient cache is pretty much same 32 because of the duplication. You just have a lot of copies out there, and which is a huge waste. So there are a bunch of partial solutions here that people use. Some of them is some form of session stickiness, so you can say, oh, this user queried this server. Then he goes again, then he's probably going to look at the same stuff, like his profile, his friends, and the data locality is going to be likely there for that user, which is helpful for some application. It also could be data-driven stuff. So it's kind of similar to a sharding, but not exactly, because you still have all the data there. You can choose their data ranges or whatever other locality for routing the queries. And the thing you have to understand here is a physical data layout. For example, you don't want to do like even odd, because the data is cached by pages, right? And that means if you want to really have an efficient caching, you need to ensure you access different pages on different slaves, not just different rows. Another approach is to route different query types on different slaves. For example, this one is used for interactive queries, this one is used for full text search, which is used for other complex queries. And this approach, beyond simply memory duplication, has other helpful point of load management. Because right now, if something happened and you overloaded your full text search slave, well, your search functionality becomes slow or stops working, but other parts of site continue to work, right? And of course, we don't want anything down, but it's better to have only some functionality not working than everything. The thing here is, when you use those techniques, it kind of makes availability handling a bit more complicated, because now your slaves are not kind of equal. They have roles, and when one of them is failing, you need to take a decision in a more complicated choice process. So we spoke a little bit about the slave specialization, and what other things we can do. Well, you can be using different storage engine, and as I mentioned, I don't quite like that, but that can be helpful in some cases. Different index structure, and even potentially to go with the first one, right? We can say have in a DB table, and then some full text search on the slave, so we can search on it. Now let's also speak a bit about using slave with replication. And the problem using slaves is usually dealing with the stale data. The data on the slave can be behind, and that may range from milliseconds, even fractions of milliseconds behind, to seconds, minutes, hours, you pick it. Slaves can be days behind sometimes if you don't take a good care of them. So, what kind of approaches we have? One of these frequently used one is query-based. No, I'm sorry, I just spoke too much. So one of them is you pick your queries and say, hey, these queries absolutely need real-time data, so we have to go to the master. And the other queries don't. We can allow to read the stale data from them, so let us stale them to the slave. And then we kind of define how stale data is okay, and say, okay, well, our other queries are reporting queries, and 1 hour lag for reporting is okay. So we can use any slave. We can keep the slaves which are up to an hour delay. Use queries on them. If something bad happens to the slave, we can kick it off from a pool and then wait to catch up. Well, another approach. Okay. It looks like I need some Coke. That's right. Dude, can you get me some Coke out there? Alright. Anyway, the other approach is session-based. The idea here is, well, you don't really have to offer the same view for all your users, right? You just have to have a reasonable user experience. For example, when you post your comment somewhere, you want to see that comment immediately, but other users viewing the same page, right, or the same data in different representations, like they don't. Thank you. They don't have to see that comment immediately. If it takes you milliseconds or a few seconds to see it, that's fine, right? And in this, one approach is to say, hey, well, especially in the low-write applications, what did you say? Hey, if I have done some data modification, I have to read from a master, right, for a certain time, like for 5 seconds or whatever, and then I can go back and read from a slave because I know my data modification is out there. The thing here is, of course, that becomes more tricky because you've got to kind of track what is happening out there in the application. Another approach is to use various ways of versioning the data. The idea is here, when we read the data from the slave, we want to understand if that data is up to date or not. And if you look at the data, most of it most of that data is very rarely changed. So for most of the data, we can read it from the slave, even if slave is hours behind, right? So, and there can be multiple flavors of implementing that, but one of them could be, okay, wherever we modify, let's say we have some data which is well, we have to pick somewhat like an object for what we will track the version. And let's say we are hosting, for example, many like thousands of blogs on the server, right? Some social token, whatever. Then object can be the user. And in this case, what we can say, hey, when user gets updated, we can store their master binary log position in a mem cache or somewhere. Now, in this case, we can, when we need to retrieve data for this user, and we have to go to the database, we can look at the position on the slave, right? And if that position is older than the data the user was last modified, we can read any data for that user. If not, then we have to go and read that data from a master or wait for slave to catch up. Right? That's, I think, another quite helpful approach to implement. Okay, that seems to be all. Okay, and this time you guys can actually ask questions. I'm not running away. Okay, I see. Yeah. Okay.
Is there any support for sharding in MySQL, or does the application have to do all the logic?
Well, there is no direct support for sharding in MySQL. There is a whole lot of stuff which is going like various add-ons. Where you can do some stuff with proxy. There is also Spock proxy. There is like Hive. There are guys doing some Spider engine for sharding support. And there is a lot of stuff that people are doing. But I would say probably most applications out there just do something, reinvented MySQL which works best for them. And that's Not a complex problem in many cases, but there is a lot of like flavor what kind of things are going to work well for you. Yes?
Well, if my slave today is 2 hours behind the master, it is quite likely that tomorrow it will be 3 hours behind the master. How come you can expect slave to catch up if you don't really?
Yes,
Well,
that is right. I mean, and I have a whole talk about yesterday about managing the slave life. Well, there could be different reasons, right? Sometimes slave can be catch up because you run some huge alter table of the master, right, or something else. That may not be the smartest thing to do, but that can be the reason. So the trend is here. You're saying, well, it's 2 hours behind and it's like constantly growing. Well, then you're in trouble, right? And if it's or maybe your, let's say, your replication stopped because of some error, right? And now you fixed it and slave is catching up, but it's now 2 hours behind. Or some people stop slaves for backups. That's another reason for slave to become 2 hours behind, but then to catch up promptly.
I think we should start the lightning talks.
Lightning talks. Okay. Yeah. No. Lightning talks.